All right, ladies and gentlemen, let's go ahead and look at parallel lines. You like my big fancy L's here for those parallel lines? Remember, parallel lines are lines that never intersect. They stay the same distance apart from each other the entire time. So today our main focus is going to be that graph and what it looks like. So remember, parallel lines will always be the same distance. Of course, my drawing is not ideal, but they'll always be the same distance apart from each other. Now, when we talk about equations of parallel lines must have the same slope. I'm definitely going to recommend you write this down if you haven't done so already. So we have the same slope. But they also must have different y-intercepts. So if you envision a graph, well, we'll look at that here in a second. If you envision a graph, they're going to have the same slope, so they're going to have the same rise and run. They'll just pass through the y-axis at different spots in order to create that distance between them. So here's our first equation, y equals negative x plus 2. We're going to write an equation in slope-intercept form of a line that is parallel to the one given. So our slope in this case is a -1. So really, I can write lots of different equations here that have a slope of -1. So I can write y equals negative x minus 2. That would create a parallel line. I can also say y equals negative x plus 6. We can also say y equals negative x minus 3. There's lots of different equations we can create of lines that are parallel. Let's actually look at this with Desmos. So y equals negative x, I believe it was minus 2. So there's our first one. Then let's go ahead and graph the same slope, of course, negative x. Let's do plus 3. If you notice, the lines are parallel to each other. They just cross at a different spot. So again, those y-intercepts are different. They're the same distance apart from each other all the way up and down this pair of lines. We can continue to graph different lines, and they will continue to be parallel as we move from one equation to the next. So if I do y equals negative x, let's go with, well, how about just y equals negative x? If you notice, that one kind of runs in the middle there. It could be plus 0 if you want it to be. It still hangs out there. You can change it to a plus 1, whatever. You can still see that those lines are parallel to one another. All right, here's another one. So here we have x equals 4. Remember, when you have x equals, that's a line that is vertical. So these are x equals, which means it crosses through the x-axis at 4. So if I want a line that's parallel, it's also going to be x equals. So let's say x equals negative 4. X equals 2. X equals 3. X can even equal 1/2. It'll still all give us those parallel lines. Let's look at Desmos. So here we have x equals 4. There's your first line. Let's try x equals, nope, that's not an equal sign. Equals, let's do 1/2, see what it looks like. There it is. We can do x equals 3. Oops, I didn't get my 3 in there. One more, let's say x equals negative 2. So there's a whole bunch of vertical lines that are all parallel to one another. All right, now in this case, because of the way the equation is written, it is written in standard form. So we have to change this to slope-intercept form to know what our slope is. So I'm going to start by subtracting 2x to move it to the other side. So I have 3y equals negative 2x plus 7. I'm going to divide everything by 3. So I have y equals negative 2/3 x plus 7/3. I can't simplify any of those fractions, so they're going to stay as is. So that means in this case, our slope is a negative 2/3. So if I'm going to write an equation that is parallel to this one, as long as I have a value different than 7/3, it's going to be parallel. So let's say, I don't know, let's go with y equals negative 2/3 x plus, let's go with just 2. We'll keep it simple. If I were to graph both of these, they're going to be parallel. They'll probably be pretty close to each other, but still parallel. I don't know if I have Desmos. We can always check that another time, but it will be parallel because the slope is the same. So these two equations will be parallel to each other when they get graphed. Next slide. I don't. But okay, so now here's another situation. In this case, we have a point that the new line must pass through. So we're going to have to do this one a little bit different. So our equation is y equals 2x plus 3. Our slope is 2. The point that we have to use is negative 3, negative 1. So then guess what? We've done this before where we have the m, the x, and the y, and we're going to substitute that in order to find the new b. So we have negative 1 equals 2 times the x we have is negative 3. I don't know why I put parentheses, but I guess I could. And then plus b. So we need to find the new b. So negative 1 equals negative 6 plus b. I'm going to add 6 on both sides. So we end up with 5 equals b. So let's write our new equation. Y equals 2x plus 5. So these two should be parallel to one another. Let's check. So it's y equals 2x plus, I have Desmos here, yay. 3. So here we go. Y equals 2x plus 3. There's our new one, or our first one, I'm sorry. Y equals 2x plus 5. There you go. You can see the two lines are graphed. They are both parallel. They are the same distance from each other all the way down and all the way up. So we have a pair of parallel lines with a slope of 2 and different y-intercepts. All right, here's another. Let's try this one. So our equation is y equals 2/3 x minus 1. We have the point 12, 5, so our slope is 2/3. The point is 12, 5. So I'm going to substitute those values so that I can write my equation. This is x, this is y. All right, so 5 equals 2/3 times 12 plus b. We're looking for that new b value. Okay. So 5 equals, let's see, 2/3 of 12. So 2 times 12 is 24. Dividing by 3 is 8 plus b. I subtract 8, so b has a value of negative 3. So here's our new equation. Y equals 2/3 x minus 3. So these two should be parallel to one another. Let's check. Oh, minus 1. Y equals 2/3 x minus 3. Was that correct? I hope. Y equals 2/3 x minus 5. There's our two parallel lines. Let me make sure minus 3. I'll change this, hopefully. It deleted it. It still should be the same. The different y-intercepts still showed that it was parallel. I'm sorry, I deleted it. I'm not going to waste our time by typing it in again. But you can see here that, or you saw that they were parallel.